All right, today let's look at how to graph an exponential function. The definition of an exponential function, or how you will know it's an exponential function versus a linear function, it will be in the form of y equals a times b to the x power. Okay, and some definitions for those variables. A is your constant term, your coefficient term. B is your base. B equals the base. A. And the very important part that makes this an exponential function is that the exponent is the variable, or you could say the variable is in the exponent. All right, some more information about each of these letters and how it could be represented and how your graph is going to look. If the base is a value where b is greater than 1, so your base is greater than 1, then the exponential function represents growth. If b is a fraction between 0 and 1, so if b is a fraction, it is called decay. And the y-intercept of an exponential function is the point 0 and then whatever the a value is. That's your y-intercept, where your graph will cross the y-axis. Okay, so let's look at a couple of examples here, and we're going to make a table of values to plot our graphs and connect it and see what the graph is going to look like. Our first example, y equals 4 to the x power. Okay, and to choose some numbers that we're going to plug into the equation for x, it's a good idea to use, we'll just use some nice ones like -1, 0, and 1. Those are pretty easy ones to plug in. If we're looking at this equation, the 4 represents b. There is no number for a in front of that. There's no extra number. There's no a, so that means your y-intercept, since there's no number for a, it's considered 1. So your y-intercept will be at 0, 1. Which we will find out when we plug 0 into the equation for x. So if I plug -1 in, y equals 4 to the -1 power. Okay, do you remember what happens with a negative exponent? What do you do with a negative exponent? Move it to the denominator. So that will put our 4 to the first power on the bottom. So flip it over like your reciprocal and you get 1/4. So the ordered pair for that is -1 and 1/4. For 0, if I plug 0 in for the x, I get 4 to the 0 power. And remember what your exponent rule says, anything to the 0 power is 1. So our ordered pair is 0, 1. And the first power, y equals 4 to the first power, would of course be 4. So your ordered pair there is 1, 4. All right, let's plot some points on the graph. At -1, 1/4, I go over to -1 on my x-axis and up to 1/4, which would be very, very, very close to 0 here. So we'll call it right about there. It's a good place to put that dot. My 0 point was at 0, 1. and my point 1 was at 1, 4. If you want to kind of extend this just in case to see what the next one would go, 2, if you use 2 for x, you're going to have y equals 4 squared, which will be 16, which will be way off the graph, somewhere way up here somewhere. Okay, so if I connect my lines, it's going to make a curve that looks like that. It's going to get very close to 0, but it's never actually going to go across the x-axis over 0. So your graph is going to just stop there. It gets very close, very small fractions, but does not ever cross over. And that's what your graph looks like for an exponential function. Okay, the next example, this one we can see we have a fraction for our b number, which is going to be decay, and that's kind of going to turn your graph around the opposite direction, and it's going to come down and curve down the other way. So let's get some points, some ordered pairs, and see what that might look like. We'll use the same numbers for x. We'll use -1, 0, and +1. Those are 3 good ones usually to use for your xy chart. Okay, so if I plug -1 in for x, we have 1/3 to the -1 power. Remember what happens with a negative exponent? Reciprocal, flip it over. So that's going to flip my 1/3 over to be just +3/1. Okay, if we plot that point on our graph, -1, +3 would go right there. If I plug 0 in, 1/3 to the 0 power. Anything to the 0 power, remember, was 1. So 0, 1. And 1/3 to the first power. Anything with an exponent of 1 is itself. So that one will be at 1/3. So we'll zoom in a little bit there and plot our point at 1 and 1/3. Give it a good estimate right about there, real close to the bottom axis, the x-axis there. Okay, if we can see the way the numbers were going, the y column, it's getting smaller. So it goes from 3 down to 1, down to 1/3. And if you kind of see where your dots are going and make a curve there, it's very similar. It's just turned backwards of the way the first curve looked. Again, it gets very close to 0. It's never going to go across. So please do not draw your graph going over the x-axis. Okay, draw an arrow going off on the other end there. And that's what that graph should look like. Okay, the third example. This time we do have a number for a, this 0.5, or we can say it's 1/2. So that's our number for a. If you remember, that was supposed to also be your y-intercept. So now this time we do have a number 0, 1/2 for our y-intercept. If you want to go ahead and kind of jot that down. If we use the typical numbers we've been using for our x, our -1, our 0, and our +1. And then we'll plug those numbers in to work out our y values and get our ordered pairs. So we have 1/2 times, I'm going to switch over to a fraction for that, 1/2 times 2 to the -1st power. Okay, 1/2. 2 to the -1st power means reciprocal, flip it over, so that would be 1/2. So 1/2 times 1/2 again is going to be 1/4. 1/2 times 1/2, numerator times numerator when you're multiplying your fractions. 1 times 1 is 1, and denominator times denominator, 2 times 2 is 4. So my ordered pair is -1 and 1/4. Come over to -1 and up to 1/4. We'll be very close right there again to 0. Very close, but not over the x-axis there. Okay, let's plug 0 in. So 1/2 times 2 to the 0 power. 2 to the 0 power is, anything to the 0 power, remember, is what? It's 1. So 1/2 times 1 is 1/2. And that's why our y-intercept comes out working out to be that 0 and then the a number at the beginning. So 0, 1/2, again, a very, very small number here, not much further up the line than your first point was. So we'll kind of squeeze it in there. And then if we plug 1 in for x, 1/2 times 2 to the first power, 2 to the first power is 2, and 1/2 times 2 is 1. So 1, 1. Now let's go ahead and do another point here just because I think it'll fit on the graph, just so we can see this a little bit better. 2, if I use 2, I'll plug in 1/2 times 2 to the second power, or 2 squared. 1/2 times 2 squared is 4, and 1/2 times 4 would give me 2. Okay, so that will be a point at 2, 2. Okay, so we got a little bit better idea of what our graph is going to look like there. Okay, and kind of give it that little sketch. Again, don't cross your x-axis there with the left end of the graph. Does not go over the x-axis. Gets very close. You can get as close as you can and kind of flattens out. It gets very, very, very flat there. But the right end of the graph goes up very steeply and sharply for that. All right, and there we go. That's another example of an exponential graph. And we'll look at one more here, just to get a good idea of all the way around, all the different things, all the different numbers we could use as far as looking at growth and decay, and having a base of a number greater than 1 and having a base of a fraction. All the different possible ways graphs could look. So if I have my equation y equals 3 times 0.5x, or 1/2 x, however you want to read that. If we look right here, we do see a number for a this time, so that means my y-intercept is that 3, y-intercept at 0, 3. We can go ahead and pull that out of the equation. We'll choose our numbers for x, still -1, 0, and +1. And plug in those numbers into the equation, work it out, and solve it out and see what our y values are going to be. So if I use -1, we'll have 3 times 1/2 to the negative first power. Negative exponent means what? Okay, it means to flip it over like a reciprocal, so that will be 3. If I flip 1/2 over, I get 2. Okay, so reciprocal of 1/2 is 2. So 3 times 2 is 6. So my ordered pair there, we get -1 and 6. Okay, plot that, -1, 6. If I plug 0 in for x, 3 times 1/2 to the 0 power. Anything to the 0 power is what? 1. So we have 3 times 1, and we will get 3 there. Remember, that's what we should have gotten. Our y-intercept, we should have 0 and 3, 0 and 3 matching. So 0, 3 is our y-intercept, and that will go here. And then our last point at 1, 3 times 1/2 to the first power. 1/2 to the first power is 1/2, so we'll just have 3 times 1/2. And we can call that, I would probably convert that to a decimal and say 1.5, just because that will be easier to plot on your graph paper than saying 3/2 or 1.5 as a mixed number. 1.5 is the number that makes the most sense to do that plotting. So 1 and 1.5 is halfway between 1 and 2. Okay, there we go. Okay, and we'll connect this line down. Alrighty, and there we go. That's going to be what that line looks like. That's a decay line. As you can see, it's coming down from the From left to right, the graph goes down, and that's what makes decay. And that's how your graph should look there.